Okay folks, so here's lesson 5 for matrices. This is the final lesson for matrices, and it's all about the transformations of such matrices. So I've written here it could include rotations, reflections and dilatations. So for example, if I give you like a coordinate 5, 2, for example, and I want you to rotate that 90 degrees about the origin, what matrix would you multiply that coordinate by? That's what we're working out. Okay, and this bit at the bottom here, I've just copied it into your textbook, and we're going to be going through this in all the examples that we're going to be doing. Okay, so that I'll explain that through the examples. Now, on your formula sheet, you're actually given one of the matrix transformations. And if you look on your formula sheet, it's at the very end of it, so the second page. And the only one you've got here is the anti-clockwise rotation through the angle theta, and then if it was like 60 degrees, you just change theta for 60 degrees. Okay, so it's anti-clockwise rotation. So you're not given like a reflection across like the y-axis or whatever, it's just this one. Okay, but that does come in very handy, as you'll see in the exam questions. Okay, so what we're going to do is we're going to do 3 or 4 examples with me, and then I'll get you to practice some, and then we'll do some exam questions afterwards. Okay, so if you can copy this into your notes jotters, just examples. Okay, and number 1, so find the simplest matrix which will reflect or rotate the following. Okay, so that's your question, and there's going to be like an A, B, C, D part of this. So part A is going to be a rotation anti-clockwise through 90 degrees. Okay, so that's your question. So I want to figure out a matrix, a 2 by 2 matrix, that if I multiply any coordinate by that, the outcome would be a rotation anti-clockwise through 90 degrees. Now, this should ring alarm bells here, anti-clockwise, because that's the only one that's in your formula sheet. So if I go back a page to my formula sheet here, you guys have all got a formula sheet. This is what we're going to be using. Okay, so see your cos theta minus sin theta and so on. That's your 2 by 2 matrix. Okay, and you know it's going to be 90 degrees. So you're changing theta for 90 degrees. Okay, so for your answer, it's as simple as this one. Okay, so for your answer, we're taking the formula sheet. Okay, so that was going to be cos theta, but theta is now going to be 90 degrees. And then it was minus sine theta, so minus sine 90, and then cos 90. Okay, so that's your 2 by 2 matrix just here. So all I want to do is just to work this out pretty much. Now this could appear in paper 1 or it could appear in paper 2. So you will be required to do it without a calculator. And just remember, it's in degrees, it's not in radians. Okay, so the easiest way that I would work out cos of 90 is just by drawing the cos graph here. Just like that. So I know that halfway is going to be 180. So cos of 90 is going to be there. So cos of 90 is just going to be 0. Okay, so that's 0, and your bottom right one is going to be 0 as well. Right? And then we've got sine of 90, and it's the minus of that. So I'm just going to draw the sine graph at the side here. And then if you go to sine 90, so know that halfway is 180. So sine 90 must be there, which is just 1. Okay, so the top right here, you've got minus sine 90. So it's just going to be minus 1. And your bottom left is just sine 90, which is just 1. Obviously, if this was paper 2, then feel free to use your calculator. Just a wee word of warning, please make sure you change it to degrees, because the question's in degrees. And then once you've done that, change it back to radians again. Okay, that's your answer. Okay, so that is the simplest matrix that reflects or rotates the following, like anti-clockwise through 90. Okay, now part B for this one is not going to be straightforward because we're not going to be given a nice formula. like this. Okay, so part B, I want to find the simplest matrix which will reflect in the x-axis. Okay, so if you look at your formula sheet, if I go back a page, the only one that's given to you is the anti-clockwise rotation. Okay, obviously a reflection in the x-axis is not the anti-clockwise rotation. Okay, so here's where we're going to use a wee method. Now this method works for all of these questions. You just need to learn the method and that's it. So for your answer, the easiest way that I found to do this is to draw a quick set of axes, just a wee quick graph. Okay, it doesn't need to be Picasso, it doesn't need to be a work of art. Okay, so there's my axes there. Just going to label it because I've got OCD. So X and Y axes. Now what you're going to do is you're going to pick a random point on here. It does not matter what coordinate you choose. Okay, so for talking sake, I'm just going to choose 2, 3, just because the numbers will be different. So go along 2, up 3, that's going to be here somewhere. So 2, 3. So pick a random coordinate, and I would recommend that you choose different numbers for them, like 1, 2, or 2, 3, or whatever. And then see if we reflect this over the x-axis. So the x-axis is here. So think of that like a mirror. If you reflect this over, the new coordinate is going to be like down here somewhere. Okay, so we've went along how many? So it's just using common sense here. You probably went along 2. So your new coordinate is going to be 2, and then you went down. So I'm going to guess it's going to be down 3. So it's going to be 2 minus 3. Okay, so if I just started with 2, 3, and if I reflect that in the x-axis, my new coordinates would be 2 minus 3. But what I need to figure out is what matrix did I multiply the original 2, 3 by. Okay, so the way that we're going to do this is we're just going to call our matrix A, B, C, D. Alright, it's a 2 by 2 matrix. I don't know what the letters stand for yet. Okay, and we took this matrix and we multiplied it with our original. So the original one was 2, 3. Okay, so this random matrix is now multiplied with 2, 3, and our end product is going to be a reflection in the x-axis, which we've worked out to be 2 minus 3. Okay, and if you set this layout out for all the questions, it will work. Okay, so just a wee reminder, you've said yourself right. A random matrix ABCD is multiplied by the coordinate we chose, which is 2, 3. And if you multiply these two together, you end up with 2 minus 3, which we know is a reflection in the x-axis. Now, focus on your left-hand side. Okay, 2 matrices. So if I just do a quick wee check, can these be multiplied together? So here we've got a 2 by 2, right? And here we've got a 2 by 1, right? Numbers in the middle, they are the same. So it means that we're allowed to multiply these. Numbers on the outside, a 2 by 1, that's what our end product is going to look like. So if we multiply these together, remember, put your left finger on the letter A, put your right finger on 2. So multiply them together. So 2 times A just gives me 2A. Left finger moves along to the B, right finger moves down to the 3. So 3 times B is just 3B. That's your top part. Right, let's finish multiplying. So C times 2 is 2C. This finger moves along to the D. This finger moves down to 3. D times 3 is just 3D. So that's your 2 by 1 matrix. And it still equals 2 minus 3. Okay, so now I want you to just look at this equation here. At your top line, I want to substitute numbers in for A and B, which is going to equal 2. Okay, now you want to stick to just zeros, ones, or minus ones for this. You don't want to start including numbers like 10 and 12 or whatever. So if you look at your top, so 2 times A plus 3 times B must equal 2. Okay, so it's just the top line we're looking at right now. If I get my highlighter to make it a bit easier. So it's this bit and this bit. So if you think of zeros, ones and minus ones, the easiest one is that A must be 1 and then B must be 0. Because 2 times 1 is 2 plus 0, which is 2. So A must be 1, B must be 0. And that works out. Then if you look at your bottom line, so 2C plus 3D equals minus 3. Okay, again, stick to zeros, ones, minus ones. So it makes sense that 2c, that c would be 0, and then 3d, d would be minus 1. Just like that. Okay, and then that's us finished. That is the matrix associated with a reflection in the y-axis. Okay, so that's what I'm looking for here. Okay, so you can just pick a random coordinate here. Alright. Part C is going to be reflection in the y-axis. So reflection in the y-axis. Okay, so again, what I would do to start off these questions is just draw a quick set of axes, just like this, and then I would choose a random coordinate and plot it. Okay, so there's my set of axes. Again, choose a random coordinate, numbers different. Let's do 4, 3, which is there. Okay, so 4, 3, like that. Okay, so I want to figure out this matrix A, B, C, D. I'm going to multiply that by the original coordinate that we've chosen, 4, 3. And if this is a reflection in the y-axis, what would the new coordinate be? So obviously our y-axis is here. So if you reflect this over, I would guess it's somewhere around here, right? So where you went left 4, so it's going to be minus 4, then up 3. That's probably the hardest part actually, just write down the new coordinate. So that's what you would get if you reflect it over the y-axis. So we would get minus 4, 3. Okay, same again, we're going to multiply out this left hand side. So left finger is on the A, right finger is on the 4. A times 4 just gives you 4A. This one moves along 1 to the B, this one moves down 1 to the 3. B times 3 is just 3B. That's your top part. Next part, C and 4, which is 4C. This one moves along, this one moves down, plus 3D. And we're looking for minus 4, 3. Okay, so again, you need to say to yourself, right, just using zeros, ones and minus ones will make sense here. So A must be minus 1, B is 3. That makes sense. So I get minus 4. If you look at your bottom line, you've got 4, 3, and then you're trying to make it equal to a 3. So it makes sense that C would be 0 and D would just be 1. Because if you had 0 times that, you'd just get 0. 1 times that is just 3, and that gives you 3. Okay, so that's the matrix that we're looking for. So this is a matrix associated with a reflection in the y-axis. Just like that. Okay. Right, final one for now. Part D. Okay, so this is going to be a reflection in the line y equals x. So again, this one is not given in the formula sheet, it's just the anti-clockwise rotation, which is in the formula sheet, I'm afraid. Right, so what we're going to do is we're going to draw our two axes here. Just going to quickly label it, my y-axis and my x-axis. Now I want a reflection in the line y equals x. So again, choose a random coordinate. Okay, so if I choose, I don't know, 1, 2. Up here, so along 1, up 2. It's just there. So I want to figure out, right, what matrix, so A, B, C, D. And if you multiply that with 1, 2, what coordinates would you get? So the line y equals x, that's just a diagonal line, just going up here. Okay, so I'm just going to draw that in green. So that's the line y equals x there. Okay, so if you reflect this over, your new coordinate is going to be like down here somewhere. If you reflect it over, which I guess, looking at these coordinates, the new one must be along 2, up 1. that would be the new coordinates there. So obviously fill it in here. Okay, so you need to figure out what this is. So same as always, multiply this out. So a times 1 is just a. Move along 1 to the b, down 1 to the 2, a plus 2b. Multiply the bottom 2, so c in the 1 just gives you c1, or c, sorry. Move along 1 to the d, down 1 to the 2, 2 times d is just 2d, and this must be 2, 1. So our matrix is, if you look at the top line, remember it's just ones, zeros and minus ones you need, so a plus 2b equals 2. The one that makes the most sense is this would be a 0, and this would be a 1. So 0 and 1. And then the bottom line, again, what would make most sense, the easiest one, is that this would be a 1, and this would be a 0. So 1, 0. Okay, so those are the four, sorry I should finish there. Those are the four main ones that you're expected to remember. Okay, now there aren't that many questions on these. Try these by yourself. Okay, so I've got 3 questions here. Pause the screen right now and try do this without looking back at your notes here. Okay, just so you get used to using or drawing your axes, plotting a random coordinate, setting this up like this. Okay, so pause the screen and I'll put the answers up in a wee second, and then we'll go through 2 past paper questions. Okay, so here are the answers that I'm looking for. So obviously the first one, you would just sub in 30 degrees in your formula sheet and you would get this. B and C are 2 that we've done before, but I just wanted you to have extra practice on that. Okay, so what we're going to do now is I've got 2 past paper questions that we're going to work through. Now these are a wee bit more difficult because you need to do 2 things in one. So this is from 2010 question 4. So obtain the 2 by 2 matrix M associated with an enlargement scale factor of 2. Okay, so we've not done that type of question yet, I'm just going to highlight that. So enlargement scale factor 2, followed by a clockwise rotation of 60 degrees about the origin. Okay, now the thing that we need to do here, because there's 2 of them, the main thing that we need to do is we need to do it in reverse order. So I know it says start with the enlargement scale factor 2 followed by clockwise rotation. What you're going to start with is the clockwise rotation. Okay, so it needs to be done in reverse order. So I'm just going to write a wee note here. So if you need more than one transformation, then do it in reverse order. Okay, so what I'm going to start with is the one and then, so the clockwise rotation of 60 degrees. So I'm just going to write in clockwise rotation of 60 degrees. Now, see if you remember, the formula sheet is just the anti-clockwise rotation. But if you think of it like your graph, if you've rotated something clockwise 60 degrees, if you start there, you'd end up with here. That's just the exact same. If you go anti-clockwise, you're just going anti-clockwise 300 degrees. And then if we go anti-clockwise, it means that I can then use my formula sheet. Alright, so I'm just writing here, or anti-clockwise 300 degrees. Right, and then I can use my formula sheet. Another way that you could do this is you could use your formula sheet and just put in negative 60 degrees or 300 degrees. It'll give you the exact same answer. You still end up at the same point anyway. Okay, so I am going to use my calculator and formula sheet, and I'm going to put in 300 degrees for my formula sheet. So it's cos theta, so it's going to be cos, obviously theta is now 300, minus sine 300, sine 300, cos 300, a little bit messy here, do apologise. So get your calculators and just pop in. Okay, so make sure your calculator's set to degrees at this point. You're going to type in cos 300 and that gives you a half. So half. Right, if you type in minus sine 300, you just get root 3 over 2, which means that sine 300 is going to be minus root 3 over 2. Cos 300 is just, again, we've worked out as a half. Okay, that's where you get your first mark from. This is a 4-mark question, by the way. Okay, let's do the bit in yellow. So enlargement scale factor 2. So I'm just going to change colour for this bit. Now, enlargement scale factor is not in your formula sheet, I'm afraid, so what we're going to have to do is draw our graph for this. I'm show it in enlargement scale factor of 2. Alright, so same as always, stick in your graph, just like this. And then what you're going to do is you're going to choose a random coordinate. I'm going to do 1, 3. Okay, so I need to work out what matrix, so A, B, C, D, that you've multiplied 1, 3 by, which gives your enlargement scale factor of 2. That just means that you multiply everything by 2. So if you start with 1, 3, you're going to end up with 2, 6. That's all it means. Okay, so you're going to end up with 2, 6. Okay, and then same as the other couple of questions, multiply this out and then you're just going to figure out what it's going to be. So this is going to give you A plus 3B, and then that's going to give you C plus 3D, and that gives you 2, 6. Okay, now I know from before I just said only use ones, minus ones and zeros, but because we've got enlargement scale factor of 2, you can use the number 2 now as well. Okay, so if you look at your top line, so A and 3B equals 2. The most obvious one would be change the A to a 2 and then change the B to a 0. Okay, and then for the bottom line, what's going to happen here? C and 3D equals 6. So if we change D for a 2 and C for a 0, that would work. Okay, so that's your matrix for a scale factor of 2. So that's your second mark here. Okay, now you might realise that all of our, or sorry, most of the matrices have a diagonal of 0 for this, and that tends to happen. Okay, so just make sure. Wait, why have I got 6 in there? That should be 2. I was just thinking ahead there. Yeah, because if C was 0 and then if D was 2, that means 3 times 2 gives you 6. There you go, so that's your second mark. Okay, now this is a 4-mark question. Okay, so we're not actually finished yet. So if I scroll back up here, you want to obtain one single 2x2 matrix associated with this and then this. So our two answers here, so you know for the top one we had this answer here, and then for the bottom one we have this answer. What we're going to do is we're going to multiply them together. Okay, so again it's in reverse order, so you're going to start with the clockwise rotation of 60, which is the one at the top. So I'm just going to get my pen again, change to pink. Hence, so let's multiply them together. So that top matrix is a half, negative root 3 over 2. I'm just going to write this down again. So half, negative root 3 over 2, and then root 3 over 2 and a half. And then this matrix, so 2, 0, 0, 2. That's your third mark, just for showing that you know how to multiply them together. Then your fourth mark is just for multiplying them together and write down your answer. Okay, so see if you ever get any of these sort of questions and you're struggling to get one of them. So say for example, if you're struggling to get your scale factor of 2, make something up, alright? You'd lose your second mark, but if you show you know how to multiply them together, you can still get your third and fourth mark. So don't give up on these questions. Okay, so let's multiply together. So my left finger is on the half, right finger's on the 2. So half times 2 just gives me 1. I'm writing this down. Then this finger moves along to the negative root 3 over 2. This finger moves down to the 0. So this times 0 is just 0, right? So it works out quite nice. Okay. And then your top right matrix. Left finger's on a half, right finger's on 0. A half times 0 is just 0. This finger moves along to this one. This finger moves down to this one. So negative root 3 over 2 times 2. 2's cancel, it just gives you minus root 3 over 2. Sorry, just minus root 3. Hold on. I wrote a question down on that. It's not a minus. The minus should be there. That's just from memory. I just wrote it down wrong. Right. If we multiply out the bottom two, obviously this is now a minus. Root 3 over 2 times 2. 2's cancel, it just gives you minus root 3. And then if this finger moves along to the half, this finger moves down to 0. That times that just gives you 0. Add on to that. Stays as minus root 3. The bottom right one, so minus root 3 over 2 times 0, it's just 0. This finger moves along to the half, this one moves down to the 2. Half times 2 is just 1. Okay, and that is your 4th mark. So 4 marks for that one. Okay, so the main thing to remember is that if you're doing more than one, which tends to always happen in the exam, always just do it in reverse. Okay, right, one final question I'm going to go through with you, and it's 2015, question 11. Now this looks like quite a lot, so what I'm going to do is I'm going to split it up into parts. So this is going to be part A, part B, part C, part D. Okay, so part A, write down a 2 by 2 matrix M1 associated with a reflection in the y-axis. So we know how to do that. So I am going to draw my axis like this. I am then going to choose a random point. Okay, so my random point, let's do 1, 2. So I am going to get a matrix A, B, C, D. You're multiplying that by 1, 2. And then if you, what was it again? Reflection in the y-axis. So if you reflect that over your y-axis, your new point is going to be there. So you went left 1, so it's going to be minus 1 up 2. Okay, so it's going to be minus 1, 2. Probably notice we do this sort of method every single question. Right, let's multiply it out. So A times 1 is A. Move along 1 to the B, then 1 to the 2. B times 2 is 2B. Same with the bottom part, you're going to get C plus 2D. And that equals minus 1, 2. Just like this. Okay, again, just using ones, minus ones and zeros. If you look at this, so hence, right, makes sense for the A to be a minus 1 and the B to be a 0. And that would give you minus 1 at the top. If you look at the bottom, it makes sense for C to be a 0 and then D just to be 1. And there you go. So that's your reflection in the y-axis, and they've just called that M1 here. So you can write it down, M1. And that's your first mark. So you might think all of that work just for 1 mark, but it is the same method that you're using for each question. Okay, right, what's part B looking for? So write down a second 2 by 2 matrix M2 associated with an anti-clockwise rotation through an angle of pi over 2 radians. Happy days. Anti-clockwise rotation means I can use the formula sheet, and it's pi over 2. All we're doing is you're popping in pi over 2 onto your formula sheet. How easy is that for 1 mark? So formula sheet is cos theta, so cos of pi over 2. Then minus sine pi over 2. And then sine pi over 2. Cos pi over 2. Again, you should know how to do this without a calculator. And you would just draw out your two axes. So if I want cos of pi over 2, this would just be cos of 90. So if I draw my graph like this, cos, so half of that's 180, and 90 must be there. Cos of 90 just gives you 0. So none of those two are zeros. If I want sine of 90, draw my sine graph. Sine of 90 is going to be up here, which is just 1. So hence that's -1 and 1. And if this was paper 2, I would just use my calculator for this. So make sure your calculator is set to radians. That's going to be M2. That gets your second mark. Okay, part C. So let's scroll back up here. So find the 2 by 2 matrix M3 associated with an anti-clockwise rotation through fibre 2, followed by a reflection. So very similar to the one before, we're going to start in reverse. So we've worked out a reflection on the y-axis. That's that part. And then you're going to multiply that by the one before that, which was your anti-clockwise rotation, or just multiply them together. So what one am I starting with again? So start in reverse. So the reflection on the y-axis, and that was from part A. Okay, so part A gives you -1, 0, 0, 1. Part B, you just get 0, -1, 1, 0. That's not enough for your third mark. What we're just going to do is we're going to multiply them together. And that gets your third mark. So left finger's on the -1, right finger's on the 0. That time that gives you 0. Left finger moves along to the 0. Right finger moves down to the 1. 0 times 1 is just 0. Okay, top right hand corner. So -1 times -1 is just 1. Move along to the 0, down to 0. 0 times 0 is just 0. Bottom left, so 0 times 0 is just 0. Move along to the 1, down to the 1. 1 1s are 1. And then 0 and -1 is just 0. Move along to the 1, down to the 0. Again, that just gives you 0. That's your third mark. Just for multiplying them together. Right, part D. What single transformation is associated with M3? So M3 is what we've just worked out before. So this is going to be M3 here. Right, so it's asking for what single transformation is associated with this. Okay, so that you need to write down, is it a reflection on the y-axis, is it a reflection on the x-axis, is it a rotation around a certain point? We don't know yet. Okay, so we've not encountered something like this before, and that's going to be like a wee problem solving question. So what I would do to start this off is I would think, right, if I'm going to multiply this by something, that would be your new like A, B, C, D. And then if you choose a random coordinate, so if I have my two set of axes here, so if I choose a random coordinate, let's say, I don't know, 1, 2, right, I want to know what I'm going to be ended up with, in case I don't know what, if I multiply this transformation by something, what's my new coordinate going to be. So if you multiply these out, obviously this is a 2 by 2, this is a 2 by 1, the middle two, that tells you you can multiply them. Your output is going to be a 2 by 1, which is like this sort of shape. So if we multiply these together, so 0 times 1 is just 0, move along 1, 1 times 2 is just 2. And then here, 1 times 1 is 1, move along 1 and down, 0 times 2 is just that. So our new coordinate, if I multiply this by the transformation, gives me 2 1s. Go along 2 up 1. Right, so if you look at this one and this one, that's one of these that we've done before. So what we've actually done is we've reflected that in the x-axis, and that's what the answer is. So reflection in the line y equals x, and that's how you get your fourth mark for this. Okay, so we didn't know what it was to begin with, so we chose a random coordinate, multiplied the transformation by that, and seen what our output is. Okay, as I've finished that question. Now there aren't many more questions to do with the reflection, rotation, and so on. So here is a final question that I want you guys to try by yourself. So pause the screen, you can see it's the same as the 2018 question 11. So have a go at this question, and if you're stuck at anything, then please let me know. But try challenge yourself to work through these by yourself, because it's easy marks that you can pick up on. Okay.